mentioned it, is an insulator and a conductor. So insulators slow energy transfer. Conductors pass thermal energy easily. So what types of materials, before you read that and look at that, do you typically think of as a conductor? Metals. So that's why most of your cooking pans and your pots are made out of metal, right? Now, some of your cooking dishes are made of stone, like I have a pizza stone, or glass. Why do you think some of them are made like that? Have you ever made a pizza on a metal pan?
Yeah.
And the bottom is burnt to a crisp and the cheese is barely melted?
Yep.
That's why, because if you cook a pizza on a metal pan, the heat is transferring to the bottom of the pizza faster than to the top because it's touching it. So that's why those Pampered Chef baking stones are such a popular thing, because I can cook a pizza in the oven all day long and it won't burn the bottom. It won't taste very good, but it won't burn the bottom. Okay, so when you look at your house or you look at this building, electricity, like all the wires, they're made out of what? Out of metal, some copper, some different metals like aluminum in the 70s, because we want that energy to conduct and flow through those wires quickly. That's why your electrical wires aren't made out of rope, right? Okay, so insulators. Insulators slow down the transfer of energy. What did we just learn is a really, really good insulator? Wool. Wool's a little bit more expensive than some of the synthetic things that you can buy, but if you want a nice warm hat or a nice warm jacket, buy a wool one because it truly will keep you warm. In the wintertime, we wear coats and scarves and hats and gloves. When I was a kid, what I didn't understand is none of those things are heating me up. What those things are doing is keeping my heat from leaving my body, but they're not actually heating me up, except for like an electric blanket, right? So that's a misconception that students have. They think that the coat is heating them up. Well, no, the coat is just keeping your heat inside your body. Okay, so all of this stuff we've talked about, thermal energy, kinetic energy, potential energy, insulators, conductors, how does that relate to the things that we did in the Engage and the things that we did in the Explore? How can you apply those things, those concepts to what we did?
Well, something insulates the energy, then it's going to keep it cold.
Yes, the can, right?
Yeah.
Okay, so you might want to go back and revisit your initial thoughts. Some of you all had like cold leaving and heat coming in. Really, is any of the cold leaving? No, the heat is entering, but the cold isn't going out. And we already talked about how those topics relate here. So let's look at explain as a part of the lesson now. Typically the explain happens at the end of the Explore. So for the Explore, it's hands-on grasp it on their own. And then you as a teacher go back in and help them understand it better in the explain. In the explain time, concepts are named and discussed. Thermal energy, potential energy, kinetic energy, conductor, insulator, those were vocabulary words that we talked about. The concept of energy flowing. This was an opportunity for you to think back to what you did. You revisited your initial drawings. You might have needed to change those a little bit. New knowledge is related to old knowledge. We talked about how we use blankets and how your mom always told you to wear a hat. Observations can become inferences. So in the explore, you observe something happening. In the explain, you make sense of it a little bit better. In the explore, most of the time it's a concrete thing that students are doing or experiencing, but then in the explain, we take it to a more abstract level, a higher level, we make connections. You don't have to write all this down. Remember this, I always have our PowerPoints in the class for you. But a lot of times in an explore, you focus student attention on an aspect of the engage or the explore experiences. You have opportunities to develop conceptual understanding. You connect, you communicate. And by the way, I did a lot of the talking in this explain. Sometimes the students do a lot of talking in the explain, or they talk to each other a lot. Students should listen to others' explanations. They should listen to the explanations offered by the teacher. They should look at their observations from the engage and the explore. They should interact. They should provide responses to the questions. The teacher formally provides definitions, explanations of new vocabulary. Again, we relate it to previous experiences. Here's the hard part. Remember at the engage, not everybody had exactly the right definition or explanation on the board. It's hard at that time not to jump in and correct that. But you can't, that's not the purpose of that part of the lesson. That comes in at the explain. Okay, I'm going to leave this up for just a second. I need to go get 3 things. Right back. explain, like, in more detail, right? Like, just take it the next step. Some people, instead of using the word elaborate, you might see, they call this part extend. I don't care which one, same thing. All right. So, we engaged, we explored, we explained. Now we're going to elaborate. So I have 3 spoons. And I have 3 pieces of ice. I'm going to have 3 volunteers come up, and they are going to hold one of the spoons. It's not hard. And we're going to see which one causes the ice on that spoon to melt the fastest. So on the elaborate page, you see you have 3 spoons. Now it says, draw how you believe heat will move as you hold the spoon. So I'm holding the spoon. What's happening with the energy here? Okay, so you're going to have to draw your hand on the spoon handle. And then the next question is predict which spoon will melt the ice the least. And after you've answered those questions, I just need 3 volunteers to come up and take a spoon.